what you have and put in negative x to the 5th power. And then we had plus 6x cubed and minus 9x. Okay, so I have the graph. I will consider maybe negative. It's the same. I already see this in here, so I really have to change the y, the negative side of y. Everything else is fine. So, and y in the window, I'm just going to change the y minimum into negative 7, and just press enter. So it's coming from infinity. It will cross at negative 0.7. It has to maximum, crossing straight, not slow, just a regular cross. It's coming to a minimum, it's coming to a maximum, and I know exactly where it is. It's 1.73, or the square root of 3 comma 0. This is negative the square root of 3 comma 0. All I need is this point. And then automatically I will get this point. So I have to determine a maximum between x equals square root of 3 and 0. Negative square root of 3 and 0. So second in calc, again I want maximum, which is 4. I'm going to say between negative the square root of 3 and 0. No, I don't want to guess, just give me the maximum. So the maximum is at negative 0.77, and the maximum is 4.46. I go back to my table, and I put them in. So this is negative 0.77, and the maximum is 4.46. Can anyone give us the minimum? Because we know it's symmetric, otherwise I couldn't. That's it. So this is a local max, and this is the local min. Can anyone identify the range? The range is already here, right? It's very clear. Negative infinity to infinity. Have we gotten the idea about the odd degree? Now we understand so much more about functions than we did before. Okay, so let's look at an even degree. So if the odd degree is compared to the linear function, what do you think any even degree will be compared to? Which function? Okay, let me repeat the question. So if all the odd degrees are compared to the linear function when it comes to nth behavior, what do you think all even degrees will be compared to? Exactly. So the n behavior will be either this for all even degree, or this for all odd degree, all even degree. That's it. So let's what would you prefer? 4th degree, 6th degree? Oh, I got a 4th degree right here, 55. Everything is the same, no secrets. F of x equals negative 3, x minus 1 squared, x squared minus 4. I'll get the chart going right away. Okay, domain, please. Very good. Degree. Careful. So when I square this, I get x squared, right? So, and something else, but the most powerful term is x squared. So x squared multiplied by x squared will give us degree 4. What is the maximum possible? It doesn't have to happen. Maximum possible number of turns. Very good. It cannot turn more than 3 times. It doesn't have to, but not more than 3. Very good. X-intercepts. I set f of x equal to 0. And I have negative 3 x minus 1 squared. Can anyone factor this for us? Thank you very much. Of course, I will divide by -3. I don't want to see it there. It's in the way. I cannot do it in a function, but in an equation I can. It's not going to change anything. How many solutions I have to find? 4 solutions, very important. I made myself a note, don't forget, 4 solutions. Even if you have to repeat them, and we know what that means. Okay, so can anyone give us 4 solutions? Oh, I'm sorry. Forgive me. Forgive me. Sorry. Sorry. My mistake. I copied it. Very good. Multiplicity for 1, multiplicity for -2, and multiplicity for 2. The sum of the multiplicities must be the number of solutions. So for the first one, 2. What does that mean? What will the function do there for sure? Multiplicity for -2. What will the function do when the multiplicity is 1? Cross. Very good. That's it. So I put these in the table, and then we'll discuss symmetry in a minute. But a function that has a turn at 2 and crosses at -2 and 2, it's not going to be symmetric. But I have to write at least a little sentence. So I have, and also let's determine f of 0, the y-intercept. Let's do this together. 0 minus 1, -1 squared. 1, right? Good. So 0 minus 4. -4 times -3, because this is 1. -4 times -3. Very good. Awesome. So 0, 12. Now I have x equals 1, which is 0. Make myself a note. Don't forget to turn. And then we have -2 and 2, which is a cross, and -2, which is a cross. So this is degree 4. It has to be compared to x squared. What is the leading coefficient? So will the function look like this, like x squared with a minimum, or like x squared with a maximum? So what is the end behavior then? -infinity to, that's it. It goes back to -infinity. And I'm going to just say that f of -x will not equal f of x, and f of -x will not equal -f of x. When you are certain, I'm fine if you just write this, not symmetric. So I know you didn't forget about symmetry. I know you did not forget about symmetry because there is no room for symmetry here. So I am going to plot what I have. I know I only have 1 minute left. Feel free to leave. I will have to finish this, and we can do it again next time. If you have to run, you have to run. So at -2, at 1, and at 2. And 0, 12, 2, 4, 6, 8, 10, 12. I changed the scale a little bit because I ran out of room. So this function is coming from -infinity and crossing here. Somehow it goes to 0, 12. But here's the problem. So I kind of have a difficulty to let me show all the options. Okay, this will be very difficult to think that it's true. Here's why. Polynomial functions are smooth continuous functions. if I have to twist my hand or my wrist in graphing it, something is not right. So see, doing this is not, it's not something that is it's fluent. It's not. I think that this is the case. And it has a turn at 1. Can it turn here? Yeah, but then I will be twisting my wrist. And I don't think that's the case. We'll see in a moment. And then if it turns here, obviously it has to turn again because it's coming and crossing at 2 and going to negative infinity. On the test paper, this is how I would present it to my professor, because I tried. I thought of all these situations, and I think that this is because they are smooth, continuous functions. They don't have corners and cusps or stuff like that. So in y equals, clear. Again, if you have to run, I understand. I just want to graph it, and I'll graph it again on Wednesday if you can stay. So this was -3. In parentheses, x minus 1. Close the parentheses, squared. Close, open another parenthesis. It was x squared minus 4. Close the parenthesis. So the viewing window, I really have no idea. Obviously, a lot higher than lower. So in the viewing window, I'm going to say from -2 to, I don't know, I see it a little bit here. I'm cheating. I'm going to say 50 with a scale of 5. And y minimum, I really don't care. Oh, this was x. I'm sorry, I made a mistake. I was looking at something else. So I want x to be -5. I want x maximum to be 5 with a scale of 1. And y minimum, not too much. -5 is good enough. But y maximum, I see it here, so with a scale of 5 or 10. And graph. Here it comes. It crosses at -2. Oh, that's good enough. Here's the 12. See how much higher? Because these functions are very smooth, continuous functions. So it's crossing at -2, comes up to a maximum. It crosses the y-axis at 0, 12. It has a turn as expected at 1, 0. It comes to a tiny maximum. Doesn't matter. It's still a maximum. And crossing at 2, 0 to go to negative infinity. So I don't want to hold you. Forgive me. We will determine the maximum here and this maximum next time. But thank you so much for staying. If you have any questions, and this completes 3.2, but I would like to look at a couple of more problems and then move on.
So you said for the purposes of this class, we won't mathematically calculate the maximums. We'll just base it off with the calculator set.
Yes.